Greetings, fellow nerds. Quick question. Is water A. attracted by a magnet, B. repelled by a magnet, or C. completely non-magnetic? Most of you will answer C, and you wouldn't be wrong. After all, in everyday life, you'd notice nothing unusual about water and magnetism. But interestingly enough, the correct answer is B. Water is actually slightly repelled by a magnet. This antimagnetic property is called diamagnetism. However, the effect is extremely weak. That's why most people don't know it's there. To see it, we need to build an extremely sensitive detector. Luckily, this is brutally simple. Just get a basin of water and put into it a styrofoam block. It's going to move around a lot, but this is actually a good thing. The styrofoam floats, and because it's so light, even the smallest force will push it around. So try and build this away from drafts and moving air, and be careful that your own breathing doesn't disrupt it. The water helps to dampen any stray motion. Now get a test tube and fill it with water and push it into the center of the styrofoam. This is the water we're actually going to measure, not the water in the basin. Now steady it, and when it's still, get a strong neodymium magnet and hold it as close as possible to the tube without touching it. Whoops, I hit it there. Let me steady it. Okay, let me try again. Slowly but surely, it's moving away from the magnet. It's an extremely weak effect, but it's happening. A perceptive viewer will also ask about the glass. And yes, the glass is also diamagnetic and also contributes to the repulsive effect. Now it doesn't matter the orientation of the magnet. There is no north or south in a diamagnetic material. It will always be repelled by a magnet. Now this video is time-lapsed. It actually moves a lot slower than this. I'll show you the actual speed at the end of this video. Moving on, I'm going to show this special material called pyrolytic carbon, sometimes called pyrolytic graphite. It's made by heating a hydrocarbon to decomposition temperature without oxygen. Pyrolytic carbon is much more diamagnetic than water, and it's pushed around quite easily. In fact, it can even support its own weight. I have here 4 strong neodymium magnets arranged with the poles facing up, but like poles on opposite corners. This creates a magnetic weak spot in the center where the pyrolytic carbon can be stably levitated. As you can see with this sheet of paper, there's nothing underneath. It doesn't matter what side it is. As said before, diamagnetic materials are always repelled by magnetic fields. Let me move the camera. As you can see, the sheet is levitating about a millimeter off the magnets, and a sheet of paper can easily be passed around it. Whoops. It can support a small piece of tissue. Superconductors are even stronger and levitate higher than water or pyrolytic carbon, but currently require very cool temperatures. Pyrolytic carbon, however, works at room temperature and can easily be purchased online. I've listed some sellers in the video description. So that's the amazing property of diamagnetism. Please subscribe, rate, and comment. Alright, so this is the actual speed of the diamagnetic water experiment. As you can see, it's really weak.